All right, welcome to The Explainer. Today, we're going to talk about something you use every single second you're online, but you probably never even think about it: the IP address.
I mean, really think about it for a second. When you hit play on a video, how in the world does that data get from some server, maybe halfway across the planet, through this massive maze of billions of computers and land right on your screen? Well, the answer is actually pretty simple, and it's a concept we all get from the real world. It all works because of a digital home address. This single idea is the key to the entire delivery system we call the internet.
And that's exactly what an IP, or Internet Protocol Address, is. It's a one-of-a-kind, unique address for your phone, your laptop, your smart TV, literally anything that gets online. Okay, let's dive into this.
To really get this, let's imagine the whole internet is just this massive, sprawling digital city with billions and billions of homes. So, on one side, you've got your regular old street address, right? The one the mail carrier uses. And on the other, you've got this string of numbers. That's the one the internet uses. The job is exactly the same. Make sure the information gets to the right place, whether that's a letter or the data for your favorite video game. You know, this whole thing didn't just pop up out of nowhere. Back in the 70s, the internet was this tiny little network called ARPANET, just a handful of computers. But as it grew, guys like Vint Cerf and Bob Kahn realized, whoa, if this thing keeps growing, we're going to need some kind of organized system or it's going to be total chaos. So by 1981, the first official system, IPv4, was born. Okay, so at first glance, an IP address just looks like a bunch of random numbers, right? But believe it or not, there's a logic to it. Let's crack the code.
Think of each of these numbers as a direction, getting more and more specific. The first number is kind of like the country, a huge network area. The next is the state or region. Then you get to the city, which is like your local network, your home Wi-Fi. And that last number, that's the house number for your specific device.
But hang on a second. Have you ever noticed that those numbers, they never go higher than 255? Why that specific number? It seems so random.
Well, it all comes down to the language computers speak, which is binary, just ones and zeros. Each of those numbers in an IP address is made up of 8 binary digits, and with 8 spots for either a 1 or a 0, you can make exactly 256 different combos. That gives us our magic range of 0 to 255.
Now, this system was brilliant for its time, but it had one massive flaw. With about 4 billion possible addresses, it seemed like plenty. But back in the 80s, nobody predicted we'd all have phones, watches, and even refrigerators that needed an address. Turns out, 4 billion was not nearly enough.
So get this. By 2011, we had pretty much used them all up. We literally ran out of internet addresses. So what did we do? We came up with a new system, IPv6. Yeah, it looks way more complicated with letters and numbers, but that complexity is what gives us an almost unbelievable number of new addresses.
So, this is the number of addresses IPv6 gives us. I'm not even going to try to say it. That is 340 undecillion. It's a number that's just so big, our brains can't really even process. To give you some kind of perspective on just how huge that is, with IPv6, you could give a unique IP address to every single atom in a human body, and you'd still have addresses left over. So yeah, I think it's safe to say the address shortage problem, it's solved. For good.
Okay, so that's the what. But how do you actually get one of these addresses? I mean, you don't fill out a form every time you connect to Wi-Fi, right? So how does your laptop get its address?
Well, for most of us, it happens automatically through something called DHCP. And the best way to think about it is like checking into a hotel. Your Wi-Fi router is the hotel manager, and it just hands out temporary room keys, or IP addresses, to any device that checks into the network.
The whole thing is super simple and totally automatic. Your phone connects, it basically yells out to the router, "Hey, I need an address." And the router just gives you one from its list of available numbers. And when you leave and come back later, you'll probably get a totally different one.
But of course, sometimes you need something a bit more permanent. That's where a static IP comes in. So while your phone is perfectly happy with a temporary hotel room number, A big company's website or maybe the printer at your office needs a permanent home address so other computers can find it every single time. All right, so who's in charge of this whole thing? I mean, with billions of addresses, it can't just be a free-for-all, right? Well, it's not. There's a whole hierarchy of organizations that are like the internet's city planners.
So way up at the top, you've got IANA. Think of them as the mayor of the internet. They're in charge of the master address book. They hand out these huge chunks of addresses to the state governors, the regional groups. Those groups then give smaller chunks to the local council, your internet provider like Comcast or Verizon. And finally, your ISP gives one of those addresses to you, the homeowner.
And this brings us to the most crucial point. You have to remember this. IP addresses aren't optional. They're not a nice to have. Just like you can't get mail without an address, your device can't use the internet without an IP address. It's completely invisible without one. So let's just quickly recap the big stuff. An IP address is your device's unique home address online. You get one automatically every single time you connect. And it's this incredibly simple yet powerful system of digital addresses that makes our whole online world work.
But this all leads to one last really important thought. If your IP address is basically your digital passport, it means everywhere you go online, you're leaving a footprint. So the question is, who gets to see that trail? And what does it really say about you?